Okay, you hear me okay in the back? It sounds kind of quiet. You're good up there? Okay, this from John Smith. The first couple of years of the Jamestown colony was, it was pretty tough. In fact, we kind of refer to at least that second winter, maybe the first winter too, as the starving time. Like they were actually called the starving time because people starved. Here was the problem. So this kind of is still on that same idea of American work ethic. So most of the people that came with the Jamestown colony, just a little bit more than half, were they were gentlemen. Well, you know, they were like the second and third son of, you know, of lords, of landed gentry. They had never worked a day in their life. I don't know what they thought was going to happen when they got here, but work was not what they thought was happening. And you know, what do they want to do? They're willing to kind of go out and look for gold. Like there's gold everywhere in North America. Just let's go find some gold. They're willing to do that, but they weren't willing to like till the ground and plant crops and stuff like that. And so it became you know, kind of tough to feed folks when no one wants to work to plant. Now, to complicate things is that the Jamestown colony for the first couple of years was a communal experiment, meaning that if you left the fort and went out and caught some fish, those weren't your fish. Those fish belonged to the colony. And so, you know, everything that you did that produced essentially got diluted by a factor of how many people were still alive in the colony. And so it made it really tough to motivate people to do anything. And so it's just kind of part of the necessity of making a new kind of home out of the wilderness. There's going to be a lot of work involved. So finally, a couple of years after they started, they put John Smith in charge. Said, John, you got to help us here. And this is one of the things he does pretty early on. He says, you must obey this now for a law, that he that will not work shall not eat, except by sickness he be disabled. For the labors of 30 or 40 honest and industrious men shall not be consumed to maintain 150 idle loiterers. Just part of what it meant in the early days to be in America is that you are going to have to work. Sorry if that's not how you were raised. And so this idea of being American is someone who embraces work, starts off from almost the very beginning. All right, save that. Oh, today we have a file to download, so starwood2.xlsm. Let's go ahead and get that downloaded. And we're going to introduce to a new topic today called arrays. First of all, I know some of you have some programming experience, so just raise your hand if you already can use arrays. Okay, a few of you, I know I can. I mean, every time I get a paycheck, I look at it and say, boy, I sure could use arrays. There's not that many jokes here, folks. You got to take what you can get. So for some reason, it turns out that array, the word array it's a normal word in the English language. It means something. What is it? Somebody look up on Google or read me a definition for an array. We're going to get the one that I want to use today. Someone's going to find a definition that I'm looking for. Anyone getting close? What do you got? An ordered series or arrangement. I love it. That's a great definition. Where'd you find that? You just typed it in, define array, and so don't leave that because I'm going to ask you to say that several times today. Say it again. An ordered series or arrangement. That's what an array. The word array means something in the English language. It's not just a programming term. So does it make sense for me to kind of gaze out across the classroom today and say, my, what a beautiful array I see? Does that make sense in English? So you're shaking your head, why not? Because you're just disorderly. You know, this class is totally disordered. You know, it's actually, I wasn't talking about the students, I was talking about the seats. The seats are totally organized. I mean, that's an array of seats if I ever saw one, but does it make any sense just to say, what a beautiful array? What do you have to add for that to make sense in English? You got to add of, and then put something else. Now all of a sudden it makes sense. What a beautiful array of students. Maybe a somewhat disorganized array of students. A beautiful array of seats. I don't know if I've seen a better array of seats anywhere. Beautiful, organized. Say it again. An ordered series and arrangement. The order is just great. There's rows and there's columns and they're all kind of going up. So for some reason, so just in normal usage, it doesn't ever make sense to say, I have an array, because you always have an array of something. An array, and the truth is, it's the same in programming as well. When you have an array, it is an array of something. But for some reason, we never say what it's an array of. We use the word array as if it was just enough to say, oh, I have an array here. But in programming, when we say we have an array, it is an array of something. Anyone know what it's an array of? If I was to say, hey, I'm making an array here in VBA, I am making an array of what? Anyone want to take a guess? It's an array of something we've already learned about in class. We spent, like a whole day on it. So it's not an array of cells. Like you might look at a spreadsheet and say, oh, read the definition again. Yeah, an ordered series or arrangement of cells. We might say that's an array of cells. And in the English, the English language definition of array, that would be right. I could look at the spreadsheet, that's an array of cells. But it's not an array in the term the way that we normally use array for the specific meaning in VBA. So it's not an array of cells, it's not an array of objects, it's actually an array of variables. Did someone say it? Did you say variables? Yes, it's an array of variables. So when I create an array, I am creating an array of variables. Anytime I say array in the context of VBA, if I don't actually say of variables, and I probably won't often say it because it's just not the way we speak of it, but that's what we're making. We're talking about an array of variables. Now I'm gonna tell you a little story. Just to remind myself mostly that this topic, this idea of creating an array of variables is now so easy and natural to me. I can do it in any language, with just kind of look at the syntax, I got it. I can deal with arrays in that language. But when I first started, it was really, really tough to get. Now, it turns out my father was, he was a general contractor. And it happened that we were visiting Uncle Jim. I was raised in San Diego, but we were visiting Uncle Jim, who had a big house in Avenues in Salt Lake in like the late 1970s. Maybe it was 78 or so. And he had a couple of apartments where the house was kind of divided, had a couple of apartments in the top end. One of his renters fell asleep smoking and caught the house on fire. And I was sleeping in like a guest room in the basement. And it's about 5 a.m. My father came in and he said, son, the house is on fire. And the firemen have asked us to get out of the house. That's what he said. Like, I'm just telling you this because some firemen, I don't really care, but the fireman wants you out of the house, apparently. Now, my father was not a prankster at all. I knew that he was serious. Sure enough, I got up, I went outside, there's fire trucks, they're spraying water on the house on fire. Anyway, Uncle Jim hired my dad to remediate the fire damage to his home. And as part of the payment, he taught my dad how to program. That's how I ever got involved in computers at a young age, was that my dad became a programmer. Uncle Jim, brilliant, like on the scale of intelligence, he's way above genius. He was just really amazing. Great programmer. And he taught my dad to be a programmer. And my dad was at best an okay programmer. He was all right, wasn't fantastic. And he was never really a very good teacher. And so occasionally when he would try to teach me something about programming, the experience was really, really painful. And that was the case when he was trying to teach me about what an array was. And so he started off by saying, array is like pigeonholes. Now, since this, I was like 12 or 13. Since this experience, I now know what he meant when he said pigeonholes. Like if you've ever dealt with like competition pigeon, homing pigeon, whatever I don't know if they call it racing or whatever, but you've got you have an array of pigeonholes. It is say it again. An ordered series or arrangement of pigeonholes, and it's like you got a whole, kind of a whole, several going across and several going up. But when he said pigeonhole, I knew what a pigeon was. And hole, I thought, well, pigeons live in like some kind of hole in the wall or something. I'm just thinking there's like a hole where pigeons live. Maybe it's just a nest. And so I'm not getting the image that he's trying to get me to evoke. And we spent that for maybe 10 minutes and I was clueless. I had no idea what he was talking about. And so he said, okay, forget the pigeonholes. It's like post office boxes. I had been to the post office by age 13 2 or 3 times, but we didn't have a post office box. And I didn't realize that array of post office boxes in the wall is a pretty good image for trying to think of what an array of variables is. But when he said post office box, we lived in rural San Diego County. And so we had like mailboxes like we have out here on a stick with, just kind of one, by themselves. And that wasn't a very good image to understand what he was talking about. Anyway, after about an hour, I was in tears. I thought, I'm a moron. I can't learn this stuff. My dad was in tears. He thought, my son's a moron. He can't learn this stuff. And we gave up. We just gave up on it. It was years. Well, maybe a year or so after that, before I ever, kind of picked up it again and thought I'm going to learn this. So that's just to help us remember that somehow this thing, which to me now seems so simple, is kind of difficult when you first bite it off. But you are in luck, because as it turns out, I'm a pretty good programmer and I'm a really good teacher. So I think I'm going to get you there today. So let's take a look at the context. Here. So I've got this worksheet open. I don't want to be on the arrays sheet. I want to be on the properties sheet. Okay, so this is some data from this, what's this called? Starwood, from the Starwood Corporation. Starwood Corporation, you've never heard of, but they own companies that you have heard of. Sheraton, you've heard of the Sheraton? Yeah, it's owned by Starwood Corporation. You've heard of the Westin Hotel? That's the Starwood Corporation. They have some other properties maybe you haven't heard of. One called the Phoenician. One called the St. Regis. So these are all kind of different, they're all different hotels, but owned by Starwood Corporation. So we have here, are these just, no, we got some in Texas, Colorado, Florida, Washington. So we got a bunch of properties here. How many do we have? It's quite a bit of them. And so that's what this data are. Now, when we look at the distance sheet, what we have here is the road distances between every hotel in the Western region. So it's like Western region road different distances. So if you're going to try to travel from the Westin in Long Beach to the Westin Kierland Resort and Spa, it's going to be 394 miles. Okay, so you can kind of look between any pair. It's 700 miles from the Beverly Hills one to the Salt Lake City to Beverly Hills, 700 miles. That's what we have here. Okay, so here's the problem that we're going to solve. Suppose, and we're going to learn about arrays in the process of doing this. Suppose that you're hired by the Starwood Corporation. So you're finally graduating and you've got your first job, and you're going to work for the main office of Starwood Corporation. Says, listen, you're out there in the West. Here's what we'd like you to do. Before you show up at our headquarters, I want you to visit, this set of 36 hotels in the Western region. And that's going to be your first assignment. We want you to go, and we'll give you like a corporate credit card, and we want you to eat at all the restaurants, that are there. Spend some time with the masseuse, just get, and for whatever, some of these are properties doing really well, others are struggling. And I just want you to kind of go and kind of get the feeling for what you're going to be doing. You got 3 months, first 3 months, that's your job. And you think, wow, I'm going to be on the road a lot. I'm married and I've got a 14-month-old, kid, or maybe, 3 or 4 kids, I don't know. And so you think, wow, this is going to be terrible. I have to be away from everyone. He says, no, you don't understand. Take your family with you, and we'll rent you a van and just, drive to all these places. Okay. So you got 3 months, you got to go 36 properties. What, if you could, describe for me the order in which you want to go to these properties. I mean, don't tell me go to Las Vegas and then go to Phoenix or something, but tell me, what would be a characteristic of the route you'd like to take? I want to take the route that is, why shortest? Why do you want to take the shortest route? Yeah, because every extra minute on the road is a minute in the minivan with the kids and 1 less minute at the masseuse, right? So you'd like to minimize the amount of time you spend on the road. Okay, so we got all the information we need to solve the problem right here. We've got all the distances between all these cities, between all these hotels. Let's calculate the route. Someone give me an algorithm. Think about how should we go about figuring out which route to take? Let me tell you what would be a really good way to do this. Plot all these places on a map and then just use a pencil and kind of draw it out. That actually would give you a pretty good solution. You guaranteed to be the best? No, I don't know, maybe not. You get a pretty good solution. This is a problem that companies really wrestle with. Name for me a company that has to deal with this problem like every day in a big way. FedEx, yeah, Amazon, Prime, UPS, right? You've got routes, you got to figure out the routes. You can't do it with, for this example, you can do it with a pencil and a paper. You can't do it in a pencil and a paper if you're FedEx, right? You've got to have an automated way to figure out what route are we going to go on to deliver all these packages. So how are we going to do it? And that's going to be our task for today and for next Tuesday, the next time we meet, is going to be to come up with an algorithm that we can use to calculate, maybe not the best route, but at least a reasonable route. Calculate us a route. So kind of think about how might we tackle the problem? Any ideas? You don't have to give me a fully formed idea, but maybe just how might we get started? I'll tell you how we get started. We're going to start in Salt Lake. I happen to know that one of these places is pretty close to here. It's this one right here. So we're going to start here. How are we going to decide where to go next? Oh, okay. So you're saying, listen, start in Salt Lake, and then we can look right across this row here, and we can say, what's the smallest number? The smallest number is right here, 425 miles to Las Vegas. That's the smallest number on that row. And so great, let's go there next. And then how do we choose to go to the next place? That's right. It turns out that when I get down here to Las Vegas, where's Las Vegas? Here. And I got to imagine kind of filling out this whole row. Of course, how come this half of the grid is blank? How come there's no number right here? Because it's the same as this number, right? So this is between the one in Tempe and the one here called Kierland. This one is the one in Tempe and the one called Kierland. So all the information is here. We could, kind of just mirror image this and we can get all the information on a row. But if I was to look here and say, well, who's the closest to Las Vegas? Turns out Salt Lake's the closest to Vegas, right? So we're going to do the closest one with one more constraint, the closest one that we haven't been to yet. And in fact, that's a pretty simple rule that we could apply over and over again. Start somewhere and then go to the next nearest hotel that we haven't been to yet. Yeah, and that describes it, right? That is virtually guaranteed not to give you the shortest route. But it's a route you could calculate. And it's a route that wouldn't be terrible. And in fact, that's exactly the algorithm that we're going to implement here in class. So if that one's guaranteed not to give us the shortest route, how could we find the shortest route? It's a little more involved than what this one is. I bet you could think of an algorithm that would be guaranteed to find us the shortest route. What would the algorithm be? You could kind of speak it in English pretty easily. Any ideas? Yep. Yeah, you can calculate every possible route. This is going to take a long time to do, but you could calculate every possible route and then just pick the shortest one. It turns out this is a really famous problem. Who knows the name of this problem? This problem is called it's the traveling salesman problem. They've been working on the traveling salesman problem since the 18th century, trying to come up with good solution to the traveling salesman problem. And you can actually you can get kind of with today's technology, you can get the best route if you got less than 25. It's kind of as soon as you cross the threshold of 25, 26 places you got to go, we just don't have the computing power to actually do it. We'll take a look at that here in just a second. So mathematicians, there have been mathematicians, like even today, who spend their career on this problem. You know, I don't know that anyone's really trying to find a way that we can come up with a solution, but they're saying, you know, how can we kind of throw out large parts of the problem space that we know aren't the solution? Now, you think about extending this in today's technology, like FedEx, it's not just who's the closest, because it turns out a left turn is way more expensive than a right turn. And so it's not just which is the shortest way, but which is the kind of the shortest, cheapest, safest. Because every time you make a left turn, what's happening? Two things are happening. One, you're waiting for traffic, and two, you're crossing traffic. So the likelihood of having an accident is increased, and the likelihood of it taking longer is also increased. So the problem really ends up being pretty complex in today's environments. So when I was first considering this as an example for this class, it seems funny to think, but it was like 20 years ago. And I thought, oh, you know what? This would be a great little example in VBA. And I thought, I'm just going to go ahead. It was this very problem. I'm going to go ahead and I'm going to do it. I'm going to calculate them all. And so I wrote an algorithm in VBA that would go through and calculate every single one. And I thought, okay, I set it to run. And I thought, oh, I'm glad I finally got that to go, because I really have to go to the bathroom. So I got up and went and came back, and it was still running. I thought, I guess it's going to take a little while to run. And so it was kind of close to the end of the day. So I went home and I came back the next day. I thought it's going to be done. Came back the next day, it was still running. Ran all night. And I thought, somehow I put myself in an endless loop. That's just not right. And so I stopped it. I broke into the code, and nope, sure enough, it was working through it. Just hadn't gotten there yet. I thought, wow, I don't know how long it's going to take. And so I calculated how many routes my computer could compute in a second. It was pretty good. It was like 5,000 routes. I thought, okay, I can calculate 5,000 routes in a second. This was like 20 years ago. Maybe it wasn't quite. Maybe it was 15 years ago. And so what's the next question? I've got to find, now I know I can do 5,000 a second. What's the other number I need to know to figure out how long it's going to take to run? How many routes are there? Okay, there are 36 properties here. I'm always surprised that someone can just throw off the top of their tongue, how do I know how many routes? How many routes is it? Not the number, but what's the formula that tells me how many routes there is? There are 36 factorial. Who said that? How do you know that? You're brilliant. That's just brilliant. Every time I ask that question, someone always goes, it's 36 factorial. And I think, that's amazing. And that's exactly right, 36 factorial. Fortunately, we have a formula, fact, which gives you factorial 36. That'll tell you 36 factorial. I never was really good with scientific notation, so let's put this as like comma. Let's put this as like a comma. Ooh. There we go. That's the number I have some. I at least have. I don't need the decimals here, by the way, in case you're wondering. Okay. I don't even know what the name of that number is, but that's how many possible routes there are. Well, let's see. I now know that I can calculate. Take that, divide it by 5,000, and that's how many I could do per second. Divide that by 60, divide that by 60. That's how many hours it is. All of a sudden, I'm wondering if I'm ever going to get this finished. Take this, divide it by 365. No, hours. That's how many hours. So by 24, that's how many days. Take this, divide it by 365. Already I'm starting to get the sense, I mean, just looking at these numbers, it reminds me of Montana. So I think it's telling me I should go to Montana first or something. That's how many, what were we, are we on days? That's how many days? Mike, what's that? That's years. My computer's not going to do it. Now, I read not that long ago that the 1 billionth PC had been produced. So they're not all in service anymore, but let's just assume that, that would be, kind of a rough estimate for what the current processing power of humanity is. And so I'll take this and I will divide it by 1 billion. That's how many years it would take to solve this problem if we devoted all of humanity's computing processing power to it. Best scientific estimate for the age of the universe. Anyone know? Yeah, like 13 billion. We're gonna give a little bit on this one. We're gonna call it 20 billion. Oh, that's finally a number I can actually say. So if we were to devote all of humanity's processing power to this, we could solve this problem in, let's see, hundreds, thousands, millions, in 117 billion times as long as the universe has been in existence. Okay, you see why we're not going to solve that, and that, by the way, is the only known algorithm to guaranteed give you the shortest route to this problem. Okay, so we're not going to find, the truth is, you could drive the worst route faster than you could calculate the fastest route, right? Really. Okay, so that's kind of the background from what we're going to do here, and we're going to choose the next nearest city algorithm. There's a name, so this is the traveling salesman problem. The next nearest city algorithm is a kind of a well-known algorithm for working on this problem, and you'll see when you get it done, we will have kind of worked through all these examples, working with, and I'll teach you how to use arrays of variables along the way, and it'll be like, wow, we did it. It gave us a route, and then we'll look at the route and we'll go, you know, we could have done better with a pencil and a map. So yeah, just be warned, there's a little disappointment coming at the end of this, but hopefully there'll be a lot of learning along the way. So let's go ahead and talk about what an array is. So let me come in here to my Visual Basic Editor. And let's see, it looks like I've already got a module here, module 1. Perfect. And I'm going to make a sub procedure here called calc route. Calc route. Okay, now what we're going to do here is we're going to create a variable. And I'm going to first make a variable just to hold the names of my hotels, which are all here, starting in row 2 in column 1. These are just all the names of my different hotels I've got to go to. So I've got 36 hotels. So I might do this, dim hotel 1 as string. Ooh, this can take like copy and paste a bunch of times. Dim hotel 2 as string, hotel 3 as string. Have you ever done this? Like you're writing variables, you know, I need a bunch of variables, they're kind of all the same. I'm just going to call them all the same thing with a number after it. Anyone? A few of you done this? Yeah, I saw a few of you doing the oh, maybe it was Big Boggle. I think I even saw someone doing the ISBN validator using something like this, but maybe not. Maybe it was Big Boggle. Okay. So I'm looking at this and I'm saying, I need a bunch of variables. They're all kind of the same name and differentiated by a number. That's exactly what an array of variables is wired to do. So here's what I'm going to do. Instead of declaring these all individually, I'm going to create all these variables at once with a single statement. I'm going to say the definition again for me. I'm going to create an ordered series or arrangement of variables. How many do I want? I want like 30, I want like 36. So dim hotel, oh yeah, that's right, dim hotel 35 as string. I am now saying, don't make one variable called hotel, make an array of variables called hotel. An ordered, organized list of variables. How many am I going to have in it? 36. Now this is a little bit strange. Why am I saying 35 if I want 36? And the answer is, when we work with arrays, we start counting at 0. And so what I'm putting here is not the number of variables I want in my array, it's the top index that I want in the array. So I'll start with 0 and count up to 35. It turns out it's possible for us to say, you know what, I just for this module, I'd like to start counting at 1 for my array. In fact, I'll show you how to do that. And then I'm going to encourage you not to do it, not in this class. So we have this option explicit showing here. Did I tell you what option explicit means? Yeah, okay. So there's another option, another compiler directive, OPTION, called option base 1. Option base 1, again, is a compiler directive. It tells our interpreter something about how to deal with this code. And we're saying, you know what, for arrays, start counting at 1. If I've got option base 1 there, I start at 1. So this would create 35 hotels instead of 36. In the vast majority of programming languages, arrays begin counting at 0. In fact, VBA is the only language, VBA and its other Visual Basic brothers and sisters, is the only one that I know that you can start counting somewhere besides 0. And it would be easier for you if we just said, you know what, use option base 1 and then you'll start counting at 1. But here's the problem. If you learn to manipulate arrays with a 1-based array, for the rest of your career, it will be a challenge every time you deal with an array that's a 0-based array. But if we go through a little bit of extra pain today to begin with option base 0, which is the default, if you don't put option base, that's what it is. So if you learn with 0-based arrays, it's really easy to make the switch to 1-based arrays. And so that's what we're going to do. So it's going to be part of what makes you better for having gone through this class. So it's a little bit stranger because we have to use 1 less than the number that we want, and we have to start counting at 0, which is a little bit odd, but that's going to be okay. So here now I've made these hotels. And so I've made these variables, 36 variables, all called hotel. And here's the way that I refer to those individual ones. Hotel, and then in parentheses, I put the one I'm after. Hotel sub 0 equals, and I'm just going to bring the text in here for the first one, just so we can kind of see it. This is what we're doing. Right, that's going to put that string into the variable hotel sub 0. That sounds like a pretty cold, it's a sub-zero hotel. It's a really cold place. I might do the second one here the same way, and then we'll look at some other ways that we could get after it. Now, whoops, this would be hotel sub 1. I could have hotel sub 2 now, my third one. I'm not sure how I keep turning the caps lock on. Now, in this one, I'm going to say, let's see, what's the name of that sheet? That sheet is the distance sheet. And view project explorer. My distance sheet is actually called distance through code. So I can, close the wrong one. So I can just say distance, the code name of the sheet, distance dot cells, row number, where are we on, row number 5? No, row number 4. Row number 4, column number 1, dot value, right? We can see that that's going to put in the next value. Like, so far, so good. We're kind of building this out. And of course, I could get the next one just by changing this to 5 and changing this to 3. We'll do one more just for kicks. Now, anytime I see, I'm writing multiple lines, 2, 3, 4, this will be 6. Anytime I see myself writing the same line over and over again, the only thing that's different is the number that's there. What should I be thinking? What should automatically pop into my head? I should be using a loop or a for loop. Yeah, exactly. So here's what I'm going to do. Let me go ahead and dim x as an integer. And I'm going to say for x equals 0 to 35. And then I'll just put one of these in here. Okay, so as I look down here, I can see this is going 0, 1, 2, 3, 4. So that's what x is going to do. So I'll just put x where that one is. Now over here, what is this? How do I make an expression based on x that will give me the right number here? Yeah, x plus 2, exactly. And then that will give me all the thing I was doing right here. I just got it now with a loop. That's nice. I guess I should kind of tab this whole thing in. And I'm going to put a breakpoint here, and I'm going to go ahead and run this. At this point, I should have my whole set of hotels start up. Let me put a breakpoint here, and we'll kind of watch it go through. So I'll run to there, and then I'll just use F8 to step through it. I'm putting in hotel 1, 2, or 0, 1, 2, 3, 4, 5. I should be able at this point to be able to ask what hotel 5 is. It's the west end. But if I try to look farther in, like the 15th, which I haven't gotten to yet, it's a blank screen, just haven't gotten there yet. If I run this until my next breakpoint, I can ask what hotel 15 is, because at this point now I've gotten through that loop and loaded that value, those values up. So one of the great things about using an array to declare multiple variables, using an array to declare an array of variables, is that now I can use an expression to identify which of all the variables I'm talking about. I don't have to spell out the whole name. I can say, oh, give me the name of the array of variables and tell me which one you want with any expression that could be calculated here. Right? I could come in here and say x equals x plus the additive identity multiplied by the multiplicative identity. And like, this is going to be some math that it evaluates out. I can do whatever I want to get to that number, and that would be okay. I mean, this isn't very exciting math. It doesn't change the value. But the point is, it doesn't have to be just a bare variable. Any expression that gets calculated down to a number that it can figure out which array, which element in the array, which variable in the array I'm talking about. Okay, show me how you're feeling about this kind of simplest version of what an array is in VBA, 0 to 5. How are you feeling? Oh, wow, 5s, excellent. Okay, it gets harder. We're moving on, but we're starting here. Now, let's suppose that I'm thinking, you know what, I'm going to have to be calculating distances, not just for the Western region, but I'm going to have to calculate some distances for the Eastern region and the Southern region and the Northern region, and I don't know what else. The middle region. What's the likelihood that those are all going to be 36 properties in all those regions? Pretty slim. So what I want to do is I want to say, no, don't just make it 36. Let's look at the problem and then decide how big to make it. This is kind of a big step. So it turns out, I don't think I've explained this to you in detail yet, but it turns out that when we go to run this sub procedure, the very first thing that happens, and the interpreter looks across the whole sub procedure, it's got to compile it. And as part of that compiling process, it says, how much memory do we need to allocate? It looks for all the dim statements, and it says, let's allocate that memory. And that happens before the first line of code executes. And so the dim statement is unlike any other statement in VBA because it doesn't get executed in order. It gets looked across, and wherever you dim them, those all get processed before it starts running, which means that this won't work. So let me find out. I'm gonna come in here and say how many hotels are there. So let me dim hotel count as an integer. Now, how could I actually calculate how many hotels I have to work with? Let's assume that I'm going to have a sheet called, my distance sheet's going to be there, and but I don't know how many there are. Any thoughts on how I might calculate that? I can assume that it's going to have this structure. I know it's going to start with a blank cell here, and it's going to be kind of contiguous data until I get to the end of the hotels, but I don't know where it's going to end. Any thoughts on how I might do it? I'd do something that can kind of look at that worksheet and come up with a number 36. Got to plug in 36 for this. So do end. Yeah, I like it. So let's do this. I'm going to say distance dot, actually, I'm going to say hotel count equals hotel count equals distance, that's my worksheet, dot range A2 dot end XL down dot row. Okay, if I did that, which one would I be on? I'd be on 37. And what I'm actually looking for here is 36. So what do you think? Just subtract 1? Yeah, I think that's going to do it for me. So now the really tempting thing to do is to say, now just use the hotel count and drop it in here. Actually, hotel count minus 1 because 0 based. I've got the number of hotels I want, subtracting 1 off to declare my array. But why won't this work? This will not work. In fact, let's see what happens if I try to run it. constant expression required. It's saying you don't get to put a variable in here. It's got to be a constant. Something the interpreter can look at and know what it means before it executes any code. That's why this fails. Because my dim statements actually gets processed before this line, even though it appears after it. You ready to see how to do it? Here's what we're going to do. Normally, when we declare an array, we start off, let's undo that, back to 35. I'm going to put it above here. We're going to start off and say, this is how many variables I want. And this is what's referred to as a static array. I've set the size for this array, but I can make a dynamic array. And the way I do it is, instead of saying how many I want, I leave that blank. So it's like, it'd be okay to put spaces in. I think they actually disappear if you leave the line. Yeah. So, I've got nothing between the parentheses. And what we're saying here is, hey, we're going to make an array. And the interpreter is thinking, well, how big is the array? And what's our answer? I will tell you how big this array is when I'm good and ready. But you just get ready for it. Okay. And so that's legal syntax like that. Now we can declare we can figure out how many we need, and now we can do this. We've dimmed it right here. We don't know how big it is. Now we're going to give it its size. We've already dimmed it, so now we're going to redim it. So we're going to redim that array to a different size. And if I've made a dynamic array, I can redim it multiple times. So I've got it here. I've just changed the size. I want to change the size again. Great. I can have another redim statement later that will change the size of it again. Now, redim is different from dim because redim is an executable statement, and I do not say the data type. Up here on dim, I give it a data type. That's the data type this array is going to be. I don't change the type of data in the array, but I can change the size with the redim statement. So I don't have any as clause over here. I just redim it to that size. So now I should be able to run this again. Let's take that breakpoint off. And that should be okay. You can still look at hotel 15 or hotel 35 and see what those are. So this is now a dynamic array. I'm setting up this array at this point saying, hey, I'll tell you what size I want to make it. And I have to redim it before I can use it. But this is now an array that I can change the size of. That's nice. Questions? Here, watch this. Let me just do one thing because there's kind of a little warning here. Let me come in here, and after my stop, I'm going to say, let's redim the hotel array again. I'm going to just add one onto my hotel array. So just whatever the count was, I'm going to add one to it. I'm going to execute that line. And by the way, we can ask an array how big it is. There's a function called ubound. It tells me the upper boundary of an array. Okay, the upper boundary is now 37. Oh, I actually added, I added 2 onto it. I should have just read them to hotel count. That would have given me 36, but I went to 37. So let's see, what was my highest one before? 35. Anyone remember the name of the hotel in 35? Let's better print it again so we can take a look at it. Are you ready? Watch. Hotel 35 is now blank. When I redim an array, it wipes out the array. And you're starting again, unless you tell it redim preserve. P-R-E-S-E-R-V. If I say redim preserve, then it should leave those other ones in there. So let me go ahead and run this again. I look at hotel 35. I'm going to redim that one. So it's redimmed. Right, we can ask what the upper boundary is. It's 37. I can look at 35 and it's still there. So when you redim, the default is it blows the whole array again and you're starting off, but you can say preserve and it will keep the values around. Okay, so that's the idea of working with a dynamic array. Questions here? So our array is a little bit better now. I'm going to get rid of this redim because I don't need it for this example here. I don't need to stop. I'll get rid of that for now too. All right. Now I still have a problem somewhere because, oh yeah, right here. The whole idea here was to make this dynamic. So if this is hard coded at 35, I'm in trouble. What should I put here? Hotel count -1. That would do it. Or I could just ask the array, right? I can ask for the upper boundary of hotel, right? Because that is going to be what the top boundary, what the top index is for referring to this array. So now this is a fully, kind of dynamic solution here that says we don't really care how many hotels there are. Load them all up into an array. Create the right number of variables, populate them with all the hotel names. And now we've got our first array for this solution. Okay, so it turns out arrays are all happening in memory. So they're non-visual. There's no way for us to just go take a look at them. So I have created on our workbook a sheet called arrays, which is just a visual representation of what we're building in memory. And we've just built this one. So here's our hotel array. It's got all these values in it. I should be able to look at number 6 and see that it is the Sheraton Phoenix Airport Hotel in Tempe. I'll run that and look at hotel number 6. And it should be that one. So logically, this is what we've built. Is it actually organized in a table in memory? No, memory is a bunch of ones and zeros. There's no table in memory. It's a bunch of ones and zeros. It happens they're contiguous ones and zeros. They're all starting at one place and kind of going for the whole array, but that's what we have here. Okay, so realize I'm not talking about this being a range. This is just a visualization of what's happening in memory. We're thinking about this being a little table with an index number that I can use to figure out which of my variables I'm talking about. So here's what we're going to do to solve the problem. Ultimately, we're trying to produce a route. What is the route that we're going to travel to go? And so I'm going to create another array called route. It's just going to be a place for me to put these in order. What's the first one? We're going to start in Salt Lake. What number is Salt Lake? Salt Lake happens to be number 1. So I'm going to put that in the first spot in the route sub 0. The next place we're going to go is Las Vegas, which is number 7. The Westin in Las Vegas. So our next one is going to be 7. So this is how we're going to build our route, just by putting the number of the hotel in the order that we want to travel it by. So I'm going to go ahead now and declare that as well. Let me dim route. Dynamic array again as, what type should I make the route? We're going to make 36 variables, but what type should the variables be in this array? Okay, if they're integer, then my range is going to be from negative 32,000. Lowest I can go in an array index is 0, no negative array indices. I think that's true. And I can go up to 32,000. That's a lot of hotels. If I used byte, what would my range be? 0 to 255. Is 255 enough? Probably, but I don't know. I like integer better. So I'm going to go with your first suggestion, integer. But the point is, I should think about that. What's the right data type to use here? And by the way, this is the time where we're going to say, here's where we can be. If we're not careful, we can use up too much memory. Because now with one statement, I'm not declaring just one variable. I'm declaring 36. That's not a big deal. But I could be declaring 36,000 variables all at once here. And now whether I'm using 2 or 4 bytes for each variable could make a difference. Okay. So I've got my route. Now I'm redimming my hotel array here. Redim hotel. Oh, this should be hotel. I'm not sure I missed this. This should be hotel count -1, right? Because my hotel count is going to be 36. And so I'm going to redim my hotels to 35. So I have 36 variables, 0 through 35. What shall I do for my route array? How big should the route array be? So my route is going to go to every hotel once. So I'm going to make it also 36. Whoops. So now by adding this line and this line, I've gotten my route array set up and ready to start putting values into. Whew. Now, as it turns out, we're going to be putting hotel IDs, right? We're going to be putting the index number for a different hotel in here. Now, let's think about what we're going to end up using this route array for. Yes, we're going to be using it for putting in the hotels that we know we've gone to, right? We're starting in Salt Lake, we're going to Las Vegas, we're going, to the next one, the next one, the next one. But the algorithm that, tell me your name again, that Tracy came up with is she said, we want to go to the next nearest one. We want to go to the closest one to which we have not yet been. And so how are we going to know if we've been there yet? How will we know if it's a hotel we've been to? The route has the list of the ones we've been to. And so by looking at the route, we can answer the question, have we been to it yet, right? Now, there's going to be a little issue here. Every variable is initialized to its default value. So my hotel array starts off as, so if we think about what happens in memory when I declare a variable, I say, operating system, give me some memory. I need a couple of bytes of memory. And the operating system says, great, here's some memory that we haven't used for a while. No one's got it reserved. You can have it. What's in that memory? In those 16 bits, 16 ones and zeros, what's there when the operating system says you can have it? Is it blank? So at a little memory address, you got two options. What can be at an address in memory? Logically, what can it be? It can be one of two values. It can be either a 1 or a 0. Can it be blank? Can't be blank. And so when you get memory, what's there? It's a bunch of ones and zeros. Well, why does it have what ones and zeros does it have there? Well, it has whatever was there the last time that memory was used for something. Now, in some programming languages, they're like, great, memory's yours, do what you want to with it. And it's starting off with whatever happened to be there. Fortunately, in VBA, they say, listen, we think it's a good idea to set all of your numbers back to 0. So you don't accidentally start with 47,822 in that number, because that's what the ones and zeros happen to mean now that you're saying, look at that as a number. So VBA says every time we make a variable, we're going to wipe out what's there and put something else in its place. And so for every numeric variable, every numeric variable, the interpreter says, all right, I got the memory, wipe it out and set it to 0, however 0 is represented for that particular type of number. Every string is wiped out to a 0-length string. So I've kind of show this as not having anything in it, but that's not true. What does this start with? I've got 36 variables here in my route array of variables. What's in there already? Yeah, this is full of zeros. So I put a 0 here and a 0 here. I should be able to, by the way, folks, if you don't know this shortcut, this is a shortcut you should learn. I can like copy cells down or copy formulas down against the contiguous range here by coming down till I hover over that little square in the corner, till I get a little black square and double clicking, and that will just fill that down. That's a good one to know. So this is what the route array really starts out with. So let me start off. I'll go ahead and start off by saying, I'm going to start off by saying start in Salt Lake. Okay, and now according to Tracy's algorithm, I have to say find the closest city to which I have not been. What cities have I been to so far? Look in my route array and tell me which cities have I been to. Salt Lake is there, but what else is there? Yeah, the Los Angeles property. This array happens to start off by saying you've already been to Los Angeles. Is that true? Haven't been. That's a problem. Okay, you see the problem? So we're initializing our hotel array by loading it up with all the names of the hotels. Let's initialize our route array by filling up with some, it's got to be some number. You can't make it blank. You can't make any number variable blank. It's got to be a number. So let's put something there that will, that we won't accidentally think we've already been to a hotel. What are some candidates? Okay, so we could put one. We could say, listen, when we're at the point where we put the first number in, just put that number everywhere. That would do the trick, because we'd ask, have you been to Salt Lake? Yeah. Have you been to anywhere else? No. That would work. Okay, I heard another answer here. 36. Oh, 36. Go one bigger than my highest one. That's a pretty good idea. There's one more idea that I like even better. So this one is a number just above. -1 would be another choice, right? Because my lowest one is 0, and then I don't even have to think about how big it is. I just put in, so let's just put in -1. Okay, so here's where I have a loop where I'm putting in, one for each hotel. So what do I put here? In fact, I want you to think through that right now and just come up with the answer. We're going to take 30 seconds for you to ponder that. What statement do I put here to put a -1 into all of my routes? Every variable in my route array. We're given 30 seconds for folks to think about it. And then I'll take your answer, Tracy. Okay, I don't know if that was 30 seconds or not, but go ahead, Tracy. That's exactly right. Route sub x equals -1. First time through the loop, x will be 0. So we'll say route sub 0 equals -1. Next time through the loop, x will be 1. Route sub 1 equals -1. Route sub 2 equals -1. Route sub 3 equals -1. And now that will give us -1. See, will that copy down or will that count? That copies down. That gives us the whole thing now initialized with -1. So now if we ask, have we been to Salt Lake? No. Have we been to Los Angeles? No. Have we been to Phoenix? No, we haven't been anywhere, because our lowest route, our lowest hotel number is 0. And so we're not going to accidentally stumble across, think we've been to a city we haven't been to yet. Oh, might have been nicer to leave that as 0s and then have it not ever take us to Los Angeles, or to take us to Los Angeles out of order and then have to track that problem down. But the truth is we don't have time to do it. So we're going to start this one off with kind of a little help from the professor. Okay. Now we've got one more array to do, and this array is different. This array is, I'm going to call it distance, and this now is a 2-dimensional array. So here's how we do an array with more than one dimension. Dim distance as, now this one, would he have just integers? Am I just, maybe I'm just showing integers. Do we have, I don't remember if we have partial. I think when I first got this data, there was like, 3.2 miles. But I guess I've taken that off. So I'm going to go ahead and use it as a single anyway. Because having fractional miles is a reasonable thing to have here. Now, if I'm making this a static array and I want it to be a 2-dimensional array that is 36 by 36, I will say 36, 36. So now I've got a 2-dimensional array. I'm saying I want, and I can think of this as rows, 36 rows, 36 columns. Is it really organized into rows and columns in memory? No, it's a long continuous stream of 1s and 0s. And so thinking of this as rows and columns is kind of only helps me think about it. Right now I've got post office boxes, I've got pigeonholes. This is what my dad was trying to start with. It was too far to start with me. So now it's going to take 2 indices to refer to that variable. Over here, it takes only 1, right? Number 6, here it is. Now to get to this one, I got to tell it which one I want. And so I'm going to say, I'm going to think of this as row first and then column. So which row do I want? Forgot which one I want right here. I want row number 4, column number 7. So I could put in here, to put that number in, distance sub 4, comma 7 is equal to, what was the number there? 301. Go ahead and run that. Oh, distance is a bad choice. Why is distance a bad choice? It's the name of the sheet. So let's call this dist instead of distance. Okay, so I've run that down there. So I should be able to look at dist sub 0, 0, my very first one. That should be 0 because it's a numeric type. It'll all be zeros. But if I look at the one that's on the 4th row and the 7th column, then I've got that value. So now I've got a 2-dimensional array. It takes me 2 indices to keep track of it. Oh, can I change the order? Can I look at 7.4? What's going to be in 7.4? Yeah, there's something there, but it's not, so the order is going to matter here. So which is it first? Is it row first or column first? Say it again. It matters where you're at. What do you mean? Right? As long as you're consistent, right? You can think of this as row first, then column, column first, then row, as long as you think of it the same way. Could you have a 3-dimensional array? Sure. You can think of rows, columns, and then depth. Could you have a 4-dimensional array? Yeah. It gets kind of hard to think about that way. How do I think about a 4-dimensional array? Well, here's how I do it. If I had 4 dimensions, I would say, all right, I'm going to think about having like a spreadsheet. Say I had 4 dimensions, comma 3, comma 9. And what I'm saying is I want to say, all right, just pretend I've got just 2 dimensions. And this is going to get me to the cell of a 2-dimensional array. And then inside of that cell, what do I have? I got another grid. And so once I get to the cell, that the right cell in that table, I look at the table that's inside that cell. And so you can get there, but it gets tougher to visualize past 3. I remember doing a problem once. I was kind of struggling with how to model the data. I think it was actually while I was a student. It was like some marketing project I was working on, when I realized, oh my gosh, I need a 6-dimensional array. It was like, oh, I think that's the only time I've ever used an array that's larger than 3 dimensions. But you can go as many as you want. Is there a limit? There might be a limit, but I'm not sure what it is. What's that? It's 60. You can have 60 dimensions? Did the book tell us that? No. You tried. You're like, oh, how high can it go? Okay. So yeah, 60 dimensions, that's a lot. Okay, we're gonna kind of cap out at 2 here. But what should I do here if I want this one also to be dynamic? Well, same thing. Declare it as a static array, as a dynamic array here. And then when I get to redimming, we're going to redim dist hotel count, comma, hotel count. It doesn't have to be square. It happens that this one's square because, we're matching up every hotel with every other hotel. But now I've got my distance hotel or my distance array set up to be the right size. We're going to make one more step here while we're still talking about defining the arrays. And then hopefully we'll get the hotel array fully initialized and we'll call it good for today. Tell me how you're feeling about arrays. We've gotten a lot more complex since I first asked. We now have dynamic arrays. We've got multi-dimensional arrays. Give me 0 to 5. Where are you? I'm seeing 3, 4, 5, 3, 4. That was funny. This morning in my advanced database class, we went over something. I said, where are you on this? And then they all were like 5. We totally got this. We did a little exercise in class. After the exercise, where are you now that we've done an exercise? Probably better. No, it was like 2. Now that I've actually tried to do this, maybe I'm a 1 or a 2 on this. So it's kind of easy to see, but when you start working with it, it's going to take a little work to get there. Okay. So it turns out that what I'm about to show you next applies to all variables, not just arrays. And that is, anytime I declare a variable inside of a subprocedure, that memory gets allocated when that subprocedure first starts to run. And it is released when the subprocedure is done running. If it gets called again, if that subprocedure gets called again, we allocate the memory again. And when we're done running, we throw it out again. Which means the only place I can access these variables is inside this subprocedure. But what if I have 2 subprocedures that I want to access the variables from? See, because I don't actually want this to be called calc route. I want this to be called initialize. And calc route is going to be actually doing the work of calculate. So make another subprocedure, subcalc route. What's that? Not yet. We're getting there. Okay, but the point is that I'm going to want to refer to all of these 3 sets of variables, and maybe hotel count too, I'm not sure. In both of these subprocedures, one's going to get my arrays set up, and the other one's going to do the heavy lifting to actually do all the figuring out. Oh, how am I going to do that? Yeah, go ahead. Oh, yeah, that's what we do. If I declare this outside of the subprocedure, and it has to be up here at the very top, all of a sudden, these variables now can be accessed by any code inside this module. Shift tab, there we go. So now my initialize will still work here. I'll go ahead and run that. Oops. Distance hotel count. Oh, that's before I have that initialized, so that's fine. So we can still run through here, and our hotel sub 3 is going to be there just fine. So I'll run this out. So I can still refer to hotel count and my hotel array if I've declared them out here. What we've just identified is there's a property of variables referred to as scope. So the scope of a variable is where can I access that variable. If it's declared inside the subprocedure, the only place I can refer to it is by other code inside the subprocedure. If it's at the top of the module, any code inside the module, I can refer to it. Well, what if I want to have a subprocedure in one module and a subprocedure in another module? Well, all I have to do for that is, instead of saying dim, use public. So public will make this globally accessible to any code in this whole project. We're not going to do that. We're going to leave it as dim here. But so there's 3 levels of scope. Local scope declared inside a subprocedure, module scope declared at the top of the module, only accessible to other code in the module, and then global scope with the keyword public anywhere in the project can refer to it. It's really tempting when you're first coding, think I'll just make everything public, then I can just get to it from wherever. You're shaking your head. Yeah, and the reason is because as soon as you make things public, everything public, you got lots and lots of public variables floating around. It's kind of really easy to kind of accidentally forget what you had up there, declare another variable at a lower level of scope. That doesn't create a problem. It just masks the one at a higher scope. So you got to be careful. So the rule is to kind of declare it at the lowest level of scope as necessary. Okay. So that's the basics of getting our arrays declared. Now I am going to load up my distances. Okay, so here, and I can actually do this with this loop here, but I think it's going to be a little clearer if I make another loop that is just for the distance. So for x equals 0 to u-bound hotel, that's okay. So what I'm going to do here is I just want to fill in the very first row of my distance array. So I want to fill in row number 0 and then going across. So I'm working here and I'm going to say dist equals, look at my worksheet, distance, D-I-S-T-A-N-C-E. Distance dot cells. Okay. Oh, it's actually, sorry, not dist. It's dist, and I got to give it its two things. Let me go ahead and start off with 0, 0 for right now. That's going to be my very first cell of my array, the very first variable in my array. And I want this to look at, why don't we say x plus 2. I want to look at distance. So my first number is, let's look at this one first, and then this is a special one. We'll treat it separately here in just a second. So I want to read the value out of this cell, which is row number 2, column number 2. So x plus 2, comma, x plus 2. I'm doing the first row, so 0, comma, x plus 2, and 0, comma, x. Here we go. So now on my number 0 row, I'm going to add in the 0 column, and I'm going to read it off the 0 plus 2, the second column of the worksheet. So I'm reading off the worksheet, writing into the array here. And that should get that first set. Let me go ahead and run that. Which one did I spell wrong? I-N-I-T and miss T-I-A-L-I-Z-E. I'm missing the A on this one. X, distance, cells, x plus 2. That should be value, but that's not the error. Okay, application defined error. Oh, that's because this isn't 0, this should be 2. There is no cell 0. So this is row 2, column 2 the first time through, row 2, column 2 is what I'm after. Next time through, it'll pick up this one, and so forth. Okay, so now I should be able to look at my dist array, looking at row number 0, column number 0 should be 0, column number 1 should be my first number, column number 2 should be my second number, and so forth. Okay. That's getting so this code is filling up my whole first row. Let's go to 35. And I've got 1139. Is that what it is? 1139. So this works pretty good. This just does me one row. I've got this. I got to do this 36 times. What should I do? Yep. Oh, I thought you were going to say cut and paste 36 times. No, a loop. Good. So we'll need another loop. Let me dim another control variable. I'll just call this one y as an integer. And then I'll make a loop around this for y equals 0 to 36, 0 to the upper boundary of hotel, to my 35 actually. And then next here, anytime I've got nested for loops, I can actually put the control variable there again. Don't have to, but I can. So now I'm going to put y here and y plus 2 here. So now y is going to get set to 0, x will get set to 0, and I'm going to go through this 36 times without ever changing y. So I'll do 0, 0. Next time through the loop, 0, 1. Next time through the loop, 0, 2, 0, 3. All the way to 35. We'll drop out of this. We'll hit the next y. So now y is 1. X starts again at 0. And so now we are 1, 0. Next time through this loop, 1, 1, and so forth. So I'm going to run this, and we're going to get a bunch of them, but we're not quite there yet. Oh, we got type mismatch. For y as integer. y plus 2, x plus 2, distance value. That's bringing back something blank. Y is 1. Oh. Okay, we've got a little more work to do on this. We're out of time. So we're going to finish off this loop first thing when we get together on Tuesday, and then we're going to finish off actually calculating the route. All right, thanks for coming. Class dismissed. What you looking for? Oh, trash can. There's one right over here.